simple arrangement of resistances in parallel. When we talk about the resistance in series, then we had added up the potential difference across each resistor and we had put it equal to the potential difference of the battery. Over here what is happening is, that is, the current flows like this. So battery is a source of energy, works like a water pump. It throws the charges, throws the current into the circuit. When the current goes into the circuit, now when it reaches over here, it has three options to split into these three paths. This will get divided. So if this is I, let's say I1 enters into this pipe, I2 enters into this pipe, I3 enters into this pipe or this arm of the circuit. So it means this I is equal to I1 plus I2 plus I3. This is nothing but obviously a conservation of charges only. So whatsoever the current enters through this junction, it should have the same value, that is I1 plus I2 plus I3, that should be equal to I only. So we say I is equal to I1 plus I2 plus I3, and the other point to note is, that is the potential difference across AB. Whether you take this path or you take this path or you take this path or you take this path remains same. It means the potential difference across resistor R, across the ends of the resistor R is V only, and across the resistor R2 it is once again the potential difference is same that is being provided by the battery, that is it is V only. Across the resistance R3 once again the potential difference is V only. So if we consider this resistance and we apply Ohm's law, so we say V, obviously the V is potential difference is V only. V is equal to I1 into R1. For the second one, once again V is equal to I2 into R2, and for the third one V is equal to I3 into R3. Also, the way we have defined the equivalent resistance, that is equivalent resistance is that single resistance which replaces in this case these three resistances, and from the same battery the same current should flow. It means that is between A and B, if we replace this arrangement of these three resistances and we simply replace by a one single resistor which we call it as Req across the same battery, the same current should flow. So obviously we should say that is for this V is equal to I into Req, or I is equal to V upon Req. If we see over here, that is V is equal to IR, this implies V upon R1 is equal to I1, and for this V upon R2 is equal to I2, and for this V upon R3 is equal to I3. I1 plus I2 plus I3, that is equal to I only. From here we get I is equal to V upon Req, that is V upon Req. What is I1? I1 is V by R1. V by R1. What is I2? I2 is V upon R2. I3 is V upon R3. V, that is not equal to 0, that can always be cancelled. So it gets 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is, you can say this is when the resistors they are in parallel, we can use this formula to find what is the equivalent resistance. When we are talking about the resistors in parallel, we have to remember that is the equivalent resistance will come out to be lesser than the least one. That is, if we have, suppose we have two resistors, one is 4 ohm, the other is 12 ohm, and over here there is a battery. This we say this is A and B. When these two resistors they are in parallel, then the equivalent resistance of these two will be lesser than the least one. That is, the equivalent resistance value will be lesser than the, what is the least one? Least one is 4. So answer will come out to be lesser than even 4 ohm. How? That is 1 by R equivalent is going to be 1 by 4 plus 1 by 12. So we can make the denominator same by multiplying this by 3. So this is 3 by 12 plus 1 by 12. So this R equivalent comes out to be 3 ohm. So this comes out to be, equivalent resistance comes out to be lesser than the least one. Whenever the resistances they are in parallel, remember that the equivalent resistance will come out to be lesser than the least one. Now we can have a various combinations of resistances in series and parallel. In some questions you will find that all the resistances they are purely in series, and in some questions you will find that all the resistance they are purely in parallel, and in some questions you will find that there is a combination of some resistance in series and some in parallel. And it may also happen that is we find that some of the resistance they are in series, some of the resistance they are in parallel, and some of the resistance they are neither in series and nor in parallel. That also we shall be understanding as we progress in this course, but for a time being we'll limit ourselves to understanding of series and parallel combination of the resistances and how to solve the questions which are based on primarily series and parallel combinations. Let's understand further these series and parallel arrangement of the resistors.